Let's prove that every primitive Pythagorean triple ABC, so a triple of integers with a squared plus b squared equals c squared, is actually of the form a is 2mn, b is a difference of squares, and c is a sum of squares for some other integers m and n. First note that every Pythagorean triple gives me a point in the circle of radius 1 by sending ABC to a over c, b over c, and if I had a point in the circle of radius 1, I could multiply by the denominators or by the least common multiple of the denominators and get a Pythagorean triple. So these two things are connected. Now, how do I find points, or how do I parameterize all the points on the circle of radius 1? I can do a stereographic projection. So I'm going to trace the line from the north pole of the circle and a line that has a slope t, a rational number t, and trace that line. That will intersect the circle at some other point. And if you have any other point that has rational coordinates, that line will have rational slope. So this construction will actually parameterize all the points on the circle. To find the coordinates of this point PT, what I have to do is the intersection of the line with the slope t that goes through 0, 1 with the equation of the circle. And if I do that, I plug y in here, then I get this equation. And if I simplify this, I get this quadratic that I can easily solve. The solutions is x equals 0, or x is minus 2t divided by 1 plus t squared. That gives me 2 points, 0, 1, which I already knew, and the second point, pt, that has these coordinates. The x coordinate and the y coordinate will be given by the equation of the line. So that gives me this point right here. But now t was a rational value, so I can, instead of writing t, I can write t as m over n with m and n integers. Now if I plug in that value of t in this expression, I get this other expression. And then if I just simplify this expression by dividing and multiplying by n squared, I get this expression over here for a point in the circle. If this is a point in the circle, plus or minus this coordinate and plus or minus that coordinate are also points in the circle, and that leads me to a over c from my original Pythagorean triple. A over c is plus or minus that expression, and b over c is plus or minus that expression. And now finally, since A, B, and C are a Pythagorean triple that is primitive, so they're relatively prime, then I can claim that A is 2mn, C is n squared plus m squared, B is minus this, so m squared minus n squared, and I get the expression that I was looking for.